Welcome. Today, we are mastering Snowflake query performance. In 2026, the era of manual, complex tuning is fading. We are entering the age of zero-tuning architecture, where the platform does the heavy lifting for you. We are going to focus on three core pillars that keep your data fast and efficient: intelligent pruning, smart caching, and the intelligent clustering service. Our goal is to let the platform work for you, not against you. Remember, focus on architectural design and governance over manual micromanagement. Let's get started. Think of pruning like finding a specific book in a massive library. You don't scan every single page in the building. You look at the labels on the shelves to find your section. Snowflake divides data into micro-partitions, typically 50 to 500 megabytes in size. These are the shelves of our data library. For every block, Snowflake stores metadata, the minimum and maximum values for every column. This allows the query engine to instantly skip data that doesn't match your filter. By skipping irrelevant partitions, Snowflake drastically reduces the amount of data scanned. This makes your queries faster and cheaper. Pro tip: keep your data naturally ordered by time or ID if possible. Because Snowflake handles this order automatically, it's essentially free performance. Snowflake has a feature called result caching. When you execute a query, Snowflake stores the result in a cache for 24 hours. If you run the exact same query again, Snowflake returns the result instantly from this cache without using any compute credits. Pro tip: your BI tools can inadvertently break the cache. If they append dynamic timestamps or unnecessary whitespace to your SQL, Snowflake treats it as a different query. This forces Snowflake to rerun the query, costing you extra money. Keep your SQL strings clean and consistent. When you run a query in Snowflake, your data is fetched from the main storage layer and temporarily stored on the virtual warehouse's local SSD. This is what we call the remote disk cache. This image shows how the virtual warehouse acts as a network mesh. These local SSDs provide a high-performance buffer, keeping data ready for your next request. If you run the same analysis again, Snowflake checks this local cache first. Because it's on local SSD, the retrieval speed is lightning fast compared to fetching it from the main storage layer. Remember, this local disk cache is specific to your active virtual warehouse. It makes repeated analysis incredibly efficient, saving both time and compute resources. In the past, database experts spent hours analyzing query patterns to manually set clustering keys. It was a tedious process of trial and error. Today, the intelligent clustering service uses machine learning to observe your real-world usage patterns. It automatically organizes your data without you lifting a finger. The AI constantly watches how your queries access data. It shifts and sorts micro-partitions behind the scenes to optimize pruning, ensuring your queries run at peak performance. The golden rule here is less is more. Unless you are dealing with massive multi-terabyte filters, let the intelligent clustering service handle the heavy lifting for you. When searching for a single record in a massive dataset, a full table scan is like looking for a needle in a haystack. It is slow and consumes unnecessary compute. The search optimization service creates specialized, persistent data structures. Think of these as a high-speed index that allows for sub-second lookups. SOS is particularly powerful for semi-structured data like JSON. It can index attributes nested deep within your documents, making complex queries lightning fast. Key takeaway: turn on SOS for point lookups on large tables. It avoids full scans, reduces latency, and optimizes cost for your most frequent, specific queries. Welcome to the anti-pattern warning. An anti-pattern is a common response to a technical problem that is actually ineffective and risky. In Snowflake, the classic example of this is overclustering. Overclustering happens when you define too many clustering keys. You might think you're speeding up queries, but in reality, you're forcing Snowflake to burn expensive credits just to constantly reorganize your data. Look at this dashboard, showing credit spikes from unnecessary background operations. This image shows why balance is key. Manual clustering should only be used if you can measure a direct, negative business impact on query latency. If your queries are fast enough, leave the data alone. Let Snowflake's intelligent automation handle the heavy lifting. Here is your key takeaway. Avoid manual clustering unless you have a proven performance issue. Always monitor your credit spend before adding new keys, and trust in Snowflake's intelligent clustering to optimize your storage patterns. Remember, in the modern data stack, less is often more. The final step in our journey is understanding that the role of the modern data engineer is shifting. Instead of micromanaging every line of SQL code, we now prioritize governance